Welcome to EDU World Space.
So to start this question, let's set it up. So here, if we apply the formula F(r) is equal to the derivative of potential over dr and Newton's third law. So for part A, the electric potential energy for a spherical shell with a uniform surface charge and a point charge Q outside the spherical shell is the same as if the shell is the point charge and it's at its center. So since this is true, and if the shell were to be replaced by a point charge, the force the shell exerts on the point charge would be the same. So by applying Newton's third law, the point charge Q exerts the same force on the shell as if it were a point charge. But Q can be replaced by a spherical shell with a uniform surface charge, and it'll be the same. So the force between the shells is the same as if both were replaced by point charges at their center. And since the force is the same as for point charges, the electric potential pair of the sphere is the same as a pair of point charges. So it's the same as a pair of point charges. Now moving on to part B. So the potential for a solid insulating sphere with the uniform charge density is the same outside of the sphere as for a spherical shell. So it's the same. So this is the same outside the spherical shell, and it's the same as the uniform charge density. So for part C, the result does not hold for conducting spheres or shells because when two charged conductors are brought close together, the force between them causes the charge to redistribute, and the charges are no longer uniformly distributed over the surface. So no longer uniformly distributed. And that's it for this question.